Hello, good evening, and welcoming you all to this lovely session where we're going to discuss our very first chapter of chemistry, that is chemical reaction and equation. So, in this chapter, we will be discussing about the chemical reaction and the equation and types of chemical reaction and many more. So, let's start our topic. First thing is, what is physical change and what is chemical change? So, physical change is a change in which no new substance is formed and substance don't loses its identity. It means that in physical substance, no new substance is formed. Let us take an example. If we take a piece of paper and tear it, what we will get? We will get two pieces of paper. The size of the paper can change, the shape of the paper can change, but still it's a paper, and the property of both the thing, the reactant and the product is same. While we are talking about the chemical changes, so it is a change in which new substance is formed and substance loses its identity. It means that when chemical change takes place, the substance loses its identity. Let us take an example of chemical change. When we take a piece of paper and burn it, it get converted into ashes and smoke, which has totally different property from that paper. So this is all about physical change and chemical changes. It is very simple that in physical change, no new substance is formed, and in chemical change, new substance is formed. I hope you are getting my points. Now come to next topic. So let's talk about the chemical reaction. Wait, in a previous example, I take an example of paper that when the paper burned, it converted into ashes and smoke. So when it get converted into ashes and smoke, if I ask that why did the paper get converted into ashes and smoke when we burn it, the answer of this question is due to chemical reaction. So what is chemical reaction? A chemical reaction is a reaction in which two or more substances react to form new substance. This is very simple, but there is some condition which is required for chemical reaction to take place. Let us see the condition. First condition is that chemical reaction take place only when two or more reactive substance comes in contact. It means that when two or more reactive substances come in contact, then only chemical reaction takes place. So here, what does reactive substance mean? Here, reactive substance means the reacting species, which can be molecule, ions, or atoms. Or we can say it as reactant, or so we can call that reacting species as reactant. Or we can say that the substance which undergoes changes during chemical reaction is called reactants. And the product that we get as a result is called the product. So the result of the chemical reaction is called the product. It is very simple. Now let us take an example like when two volume of hydrogen reacts with one volume of oxygen, it gives H2O. So here hydrogen is reacting with oxygen and giving us water. It means that here hydrogen and oxygen are reactants and water is the product that we get as a result. So I hope that you are clear with reactant and product. Now let us see the next condition. In this reaction, absorption and release of heat, light and electricity. So yes, if any chemical reaction takes place, we have to give a proper condition to make that chemical reaction possible. Now the third point is that during chemical reaction, color of substance can change. Yes, during chemical reaction, color of substance, and not only color of substance, the temperature can also change. There are some characteristics of chemical reaction like change in color, change in states, that is solid to liquid, liquid to gas, evaluation of gas, formation of precipitate. Here precipitate means an insoluble substance, or you can also say an insoluble salt. Now come to next topic. So yes, as I said that change in temperature is one of the characteristic of chemical reaction. So here on the basis of temperature, there are two types of changes. We already familiar about this. In our previous classes, we have studied about all the stages and all this reaction. So this is our first reaction, that is exothermic reaction, and our second reaction is endothermic reaction. In exothermic reaction, energy is evolved during chemical reaction, and that's why it is called exothermic reaction, because energy is releasing, it is evolving. Let us see an example of exothermic reaction. When CaO, means calcium oxide, reacts with H2O, it gives calcium hydroxide and heat. So here, heat is evolving. In this reaction, you can clearly see that when carbon oxide reacts with water, it gives calcium hydroxide with heat. So here, heat is evolving. In the next reaction also, when carbon reacts with oxygen, it gives CO2 plus heat. Here also heat is evolved. So whenever in any reaction heat is evolving, we can say it as exothermic reaction. When we are talking about the endothermic reaction, it required energy to take place. It means that here we can see in this example that when we pass heat to CaCO3, that is calcium carbonate, it converted into calcium oxide and carbon dioxide. So here we are giving heat to calcium carbonate to get converted into calcium oxide and carbon dioxide. So this is called endothermic reaction. Now come to next topic. So now we had studied about the chemical reaction, its characteristic, how do you identify that a chemical reaction takes place. Now let's talk about the types of chemical reaction. There are many types of chemical reaction, but here we will discuss about 4 types of chemical reaction. First one is combination reaction, second one is decomposition reaction, third is displacement reaction, and the fourth is double displacement reaction. Now let's talk about each and every reaction in a specific slide. So here, the first reaction, that is combination reaction. Let us see the definition. A reaction in which 2 or more substances combine to form single new substance. It means that the reaction in which 2 or more substances combine to form just a single substance. Here, when AB combine, it gives AB, which is drawn now. So with name we can see that when 2 reactants are combined and giving the product, then we can call it as combination reaction. Now let us see the example. Here, when calcium oxide reacts with H2O, it gives calcium hydroxide. So in this reaction, we can see that here two reactants are combined to give a single product. So this is what combination reaction is. Or now let us see the next example, that is SO4. When SO4 reacts with H2O, it gives H2SO4. It is sulfate, reacts with water, it gives sulfuric acid. So this is how sulfuric acid formed, and this is the formation of calcium hydroxide. I hope you are clear with this. It is very simple that when 2 substances combine to form new substance, it is called then combination reaction. Now come to next reaction. Now let us see another most important example of combination reaction. That is when Mg reacts with O2, it gives. Now let us see one of the most important example of this reaction. That is when magnesium reacts with oxygen, it gives magnesium oxide. Please give a star mark to it because it is very important reaction. When magnesium reacts with oxygen, it gives magnesium oxide. Now come to next reaction, that is decomposition reaction. Before studying this reaction, I want to discuss you something, that this reaction is opposite of our previous reaction, that is combination reaction. So what we are doing in combination reaction, we are combining 2 reactants, but in this reaction we are splitting we are splitting reactants, we are splitting the products. Let us see the definition. So, reaction in which a compound splits into two or more fragments. Okay. So now let us see the example. When NaCl reacts, it gives sodium plus chlorine. In this reaction, we can clearly see that when NaCl is reacting, it gives Na and C, sodium and chlorine is splitting. So this is what decomposition reaction is. When we are talking about the calcium carbonate, then it will separate into calcium oxide and carbon dioxide, or which. So, as I said that in decomposition reaction, the substance splits into two parts. So here we can clearly see that when we pass electric current to molten sodium chloride, it will split into sodium and chlorine. And in the next example, also we can see that when we pass heat from calcium carbonate, it will convert into or split into calcium oxide and carbon dioxide. Now let us check, as I said before starting this topic, that decomposition reaction is opposite of combination reaction. So here we can see that when calcium oxide reacts with carbon dioxide, it will give CaCO3, that is calcium carbonate. So this is very important thing about this two reaction. When you memorize any one of them, you will automatically memorize the another one. Now let us go to next reaction, that is displacement reaction. So here displacement reaction, from name we can, a thing that came in our mind is displaces. So yes, here the reactants, or you can say the substance, displaces according to this reactivity series. So before studying this topic, you have to learn about the reactivity series. What is reactivity series? We can see that here potassium, sodium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold, platinum. These all are in reactivity series, and it is in vertical order. Like when here we can say that mercury is more reactive than silver, and copper is more reactive than mercury, hydrogen is more reactive than copper, and so on. So we can learn, this is very important for displacement reaction. Now let us see the definition of displacement reaction. More reactive element replaces or displaces less reactive element, then it is known as displacement reaction. As I said that when that in this reaction the substance displaces. So according to the reactivity series, here more reactive element will displace less reactive element. As in this example, we can see that when Fe2O3 reacts with aluminium, it gives Fe plus Al2O3. It means that here, as you can see, that aluminium is more reactive than iron. So here aluminium is displacing iron. When we can see that here iron is alone and aluminium is just taking place of iron. So here, as we can see that in this example, more reactive element, that is aluminium, which is more reactive than iron, is displacing iron. Here aluminium is displacing iron, or we can see that, or we can say that here aluminium is taking place of iron. So this is all about displacement reaction. If we learn or memorize the reactivity series, then we can easily identify that displacement reaction. Now let's come to next reaction, that is double displacement reaction. So double displacement reaction. Let us, before studying the definition, I want to tell you something about this reaction, that in this reaction changes of ions takes place. Now let us see the definition, that reaction in which radical of two different compound is exchanged to gives a new compound, then we call it as double displacement reaction. Let us see the example, that when silver nitrate reacts with sodium chloride, it will give silver chloride and sodium nitrate. In this reaction also, here chlorine is displacing As in this reaction, we can see that the change of ions takes place. Here, Cl is here instead of Cl, NO3 is coming. So here also a exchange of ions takes place. And in this example also, there is exchange of ions, as you can see. So now let's come to our next topic, that is balancing the equation. In our previous classes, we had already studied about the law of conservation of mass, which states that mass can neither be created nor be destroyed in a chemical reaction, or you can say that mass of reactants is always equal to the mass of products. Now see, when we say that hydrogen reacts with oxygen, it gives H2O. You can see that this reaction is not balanced, and when the reaction is not balanced, we call it as unbalanced reaction or skeletal equation. Now let's balance it. So here there is 2 hydrogen and here is also 2 hydrogen. So here in this reaction, now hydrogen is balanced. Now come to oxygen. Here oxygen is 2, but here there is only 1 oxygen, means oxygen is not balanced. So if we add 2 here, now there's 2 oxygen in the product side also and 2 oxygen in the reactant side also. Let us write this. 2 in reactant side and 2 in product side. Now talking about hydrogen. Now check the another reaction, another substance again. Here there is 2 hydrogen, but here there is 2 into 2, 4 hydrogen. So we will balance it. If we add 2 here, then now this reaction is balanced. We can check that 2 into 2. Here there is 4 hydrogen, 2 oxygen, and here also that there is 4 hydrogen and 2 oxygen. So this is about balancing equation, and it is very important to balance the equation to satisfy the law of conservation of mass. So and when the balance equation is not balanced, then we call it as skeletal equation. This is about chemical reaction and equation. Thanks for watching. If you like this video, please like it, share it and subscribe it. Thank you.